This section is on graphing parabolas. So parabolas are really of the form y is equal to ax squared plus bx plus c. So when we were solving quadratic equations, when you go and you put a y on the one side instead of like a 0 there, or set it equal to a number, just a y, and you have all the other guy on the other side, it looks like a parabola. And what is a parabola? What does it even look like? It looks like this, or like this, or like this, or like that. Okay, similar. And in function notation, it looks like this. F of x is equal to ax squared plus bx plus c. And then we'll introduce that notation as we need to. The value of a for the parabola is not equal to 0. Otherwise, the graph is linear. So there always has to have an x squared in the problem in order for it to be a parabola. And we've graphed linear equations. They're lines, right? But we already know how to do that. Now we're going to do this next piece. Okay, so there's like 5 bullets here. To decide whether the parabola opens up or down, the a value is your determining factor. If it's positive, the parabola opens up. Negative, the parabola opens down. The vertex, the x-coordinate of the vertex is negative b over 2a. What the heck is a vertex? It's either the highest point on the parabola if the parabola opens down, or the lowest point on the parabola if it opens up. Good? And then once you get the x-coordinate of the vertex, you can get the y-coordinate. Then we're going to make like a symmetry table to help us get some other points on the parabola. And then probably we're going to have to figure out where it crosses the y-axis and where it crosses the x-axis. Boom, bah, we're done. Okay, let's take a look at this one. Well, we realize that A is equal to 1, B is equal to 4, and C is equal to 4. So it opens up like a cup. So now let's build a symmetry table. Yeah, let's. So here we go. We need to get the x coordinate of the vertex. And how do I do that? Well, x is equal to negative b over 2a. So negative b, negative 4 over 2 times 1, which is a negative 2. So we're building the symmetry table. Negative 2 in the middle. And let's do negative 1, 0, and negative 3, negative 4. The beauty of this is I only have to plug in 3 values and the other ones will follow, which we love, right? So here we go. When x is equal to negative 2, we plug in negative 2 squared plus 4 times negative 2 plus 4. Negative 2 squared is a regular 4. Take away 8 plus 4. Oh, it's 0. So there we go, negative 2 comma 0. Now let's plug in negative 1 for x. So y is equal to negative 1 squared plus 4 times negative 1 plus 4. So 1 minus 4 plus 4. So that's 1. So bam-a-lamb, I have the one at negative 3. Done. Now let's do one more. Let's plug in 0. So when x is equal to 0, we get y is equal to 0 squared plus 4 times 0 plus 4. So y is equal to 4. Bam-a-lamb, I got the other one. So where's the vertex? The vertex is negative 2 comma 0. That's my vertex. Perfect. So let's graph. Label my axes, right? Graph the points. Negative 2, 0. Let's graph in blue. Good. Negative 1, 1. Negative 1, 1. And let's graph the other guy. Negative 3, 1. Good, because I got my little symmetry going on. I love the symmetry aspect of the parabola. And then 0, 4, and negative 4, 4, and then I can connect. Okay, perfect. So let's read it off the graph. What is the y-intercept? Where does it cross the y-axis? It crosses it at 0, comma 4. What's the x-intercept? Well, that crosses the x-axis at negative 2, comma 0. So in this case, it just comes down, touches the x-axis, and comes right back up. So it only crosses it once. And this is actually called tangent to the x-axis. You can impress your friends with that. One more example.